Friends, I am Fred Asibe, your subject teacher. In today's lesson, I will be teaching on triangle. Yes, you heard me say triangle. Yes, that's today's topic. But before I proceed, I want you to look at the objective of today's lesson. Now, the objective of today's lesson is that by the end of this lesson, you should be able to define triangle. That you should know definition of triangle. 2, you should be able to know the types of triangles and also how to name the parts of a triangle. Finally, being the third one, you should be able to construct triangle. Now let's proceed. Now you recall in the previous class, we started with circles. Now I want to look at triangle today. Now what is triangle? Now a triangle is a plane figure bounded by 3 straight lines. Let me come again. A triangle is a plane figure bounded by 3 sides. Now, if you don't want to say it that way, you can also say a triangle is a plane figure bounded by 3 straight lines. Now, this is a triangle. The set square I'm holding now has a triangular shape. So as you can see, this is 3-sided place I'm talking about. Remember I told you a triangle is a plane figure that is bounded by 3 straight lines. This is a straight line. This is another straight line. This side is also a straight line. So what it means is that a triangle is a plane figure bounded by these 3 straight lines. Sometimes the definition can also have it this way, that is a plane rectilinear figure with 3 sizes. A plane rectilinear figure with 3 sizes. So that's what a triangle is. Now, having known what triangle is, now we all know that the sum of angle or sum of total of all the angles in a triangle is 180. Yes, you heard me. That the total sum of angles in a given triangle is 180 degrees. Now, you may say, okay, this is example of triangle. This shape is also a good example of triangle. Now, every triangle has its parts. Let's talk about the parts of triangle. Now, the parts of triangle include what we call, you can see, let me draw this example. Let's take this as example as a triangle. Supposing we're about to draw a triangle. Let's take this shape. It's a good example of a triangle. Now suppose this is point A, and this is B, and this is C. Now, this point where these 2 straight lines meet is called the vertex. We call this vertex. Vertex. Yes, vertex. Then, you should also know that this vertical point here from A to B is called the attitude. If you don't want to call it attitude. If you don't want to call it attitude, you can also call it the height, the vertical height. Vertical height. Yes, AB is the attitude, or called the vertical height. Why this BC can be called the base. This is the base. Yes, base. Remember I told you when a 2 straight line meets at a point, this is vertex. This is also a vertex. It's a vertex. Why this AB, that's this vertical line here, can be called the vertical height, or you can call it the attitude. Why this horizontal one here, BC, is called the base. So they are the parts of the triangle, just like we earlier described for that of the circles. We have the parts of the circles like diameter, radius, circumference, tangent, and so on. So our sectors, they are all examples of the parts of circles. But this time around, we are talking about triangles. So the parts of triangles include what we call the base, the height, the vertex. These are the parts of triangle. Now, having known this, we have to look at, having known the parts of the triangle, we have to look at the next subtopic. That is what we call the types of triangle. Types of triangle. Now, types of triangle, when we talk about the types of triangle, triangles can be described by their length of their sizes. You can also describe triangles by the sizes of their angles. You also can describe triangle with the consideration of both the length of the sizes and also the sizes of the angles. Now remember, I told you again that types of triangles can be described. We have different types of triangles, and these triangles can be described according to the length of their sizes. You can also describe a particular triangle with the sizes of their angles. You can also describe triangle as a result of the consideration of the both length of the sizes and at the same time the sizes of the angles. These are the different ways you can describe a triangle. Triangle does not just have a particular name. That's why you see them having different names. And those names is reflecting to these descriptions. It has to do with these descriptions I just described now. Now when we talk about the describing triangles, types of triangles described by their angles. A good example is what we call the equilateral triangle. Yes, equilateral triangle. You heard me, equilateral triangle. Now, equilateral triangle is one of the types of triangles. We are talking about types of triangles. Let me just call it types of triangle. Types of triangle. Yes, types of triangle. We have what we call the equilateral triangle. Equilateral triangle. Yes, equilateral triangle. Now, equilateral triangle is one of the types of triangle. Now, what is this equilateral triangle? The equilateral triangle is a triangle that has all its sizes equal. Or you can also say it's a triangle when the three sizes are what? Equal. If you don't want to define it that way, you can also say an equilateral triangle has three equal sizes and angles. So what do we mean by that? It means that in equilateral triangle, all the sizes are equal. So look at this set square now. We don't have equilateral because these two sizes here are equal, but they are not the same with this. So this is not an equilateral triangle. This one, all the sizes here are not equal. So this is the equilateral triangle is not here. So when we talk about the equilateral triangle, it means that you should have a triangle this way. You should have this kind of a triangle where if you have here as A, B, and this is C, the A side, AC here, should be equal to CB or BC, and the AB should be equal to this. And each angle here should be equal to this angle. And remember I told you that the total sum of angle in a triangle is 180 degrees. The sum of angle in the triangle is 180 degrees. So what it means is that if you divide 180 degrees equally into three parts, each angle here is 60 degrees. 60 degrees. 60 degrees. That's why it is called equilateral triangle. So all the angles are equal. All the angles in the equilateral triangles are equal, where each angle is what? 60. So if all the sizes are equal, that is the reason why it is called equi. Equi means equal. Triangle that has equal sizes. The size AB is equal to BC. BC or CA is the same thing as AB. So all the sizes are equal. Since all the sizes are equal, all the angles are also equal. And each angle in the equilateral triangle is 60 degrees. Now let's look at the second triangle. Now the second triangle is what we call the isosceles triangle. Isosceles triangle. Isosceles triangle. Yes, isosceles triangle. Yes, excellent. Isosceles triangle. Now, isosceles triangle is a triangle that has two equal sizes and angle. You can also say it's a triangle whose two sizes are equal in length. When the two sizes of a triangle are equal in length, then you can call that what? Isosceles triangle. For instance, the set square here is isosceles triangle. Now look at this set square. This side here, if you measure this side with this side, it is the same sizes. They are all the same sizes, but they are not the same with this. So this triangle is an isosceles triangle. Is that clear now? So this is an isosceles triangle. So it's a good example of isosceles triangle. So that's why we say an isosceles triangle is a triangle whose two sizes are equal in length. So the base angles are also equal. So if you look at the base angle here, they should be equal. So if you have something of this nature, let's take this as an instance. This is an isosceles triangle. We are just trying to conserve space. The side here, this side here, is not equal to this side, but this side is equal to this side. So what it means is that the base angle here and angle here are equal. If this is 90 degrees, for instance, this place should be 45. This place should be 45. If you sum these angles now, they are all equal to 180 degrees, which is the total sum of angle in the triangle. So that is a good example of isosceles triangle. So the two sizes here are equal. And one of the angles, like for example here, the two base angles are also what? Equal. So that is exactly what we call the isosceles triangle. So it's a triangle that has its two sizes equal and their base angles are also what? Equal. Now we have another one we call number 3. We call the Scalene triangle. Scalene triangle. Yes, Scalene triangle. Now when you look at the Scalene triangle is a triangle that has 3 unequal sizes and angles. You heard me. Scalene triangle are triangles that have 3 unequal sizes and angles. So what it means is that a Scalene triangle is a triangle that have none of its sizes equal in length. So since all the sizes are not equal in length, it means they have different what? Angles. Like this. This is a Scalene triangle. If you have to measure this now, this is a Scalene. Because the size here is not the same size here, and the size here is not the same. So since all the sizes are not the same, so the angles are also not what? The same. So they are unequal sizes. So that's why we say it's a Scalene triangle has unequal sizes and angles. The angles are not also equal. Like for instance, let me just have a shape of this. Now let me take this shape. This is a Scalene. You see, if you have here as 90 degrees, this place is 60. This is 30. And you see, this side is not the same thing with this side. And this side is not the same thing as this. So this is exactly what a Scalene triangle is all about. So as you can see, the Scalene triangles has 3 unequal sizes and angles. The angles are not the same. This is 90 degrees, take note. So this is 90 degrees. So that's exactly what the types of triangles we have. Not only that, we also have these other triangles. Somebody may think, well, this is where the triangle, we have a equilateral triangle, isosceles triangle, Scalene. We also have another triangle we call the right angle triangle. Right angle triangle. Yes, right angle triangle is a triangle that has each one of its angle equal to 90 degrees. You heard me. It's a triangle that has one of each angle as what? 90 degrees. So a right angle triangle has each one of its angle equal to 90 degrees. This is a good example. The two set square you see, they are all right angle triangle. But remember we said that this is isosceles because all the two sizes are equal. That does not mean that this is not equal to this. This is also a Scalene triangle. Now when you look at this triangle, what actually makes it a right angle triangle? Because one of the angle here is 90 degrees. This angle here is also 90 degrees. So a Scalene can also be right angle triangle. That's what it means. And the isosceles can also be right angle triangle. So, but not equilateral, because equilateral all the angles are 60 degrees. each angle there is 60 degrees. So you can have an isosceles as a right angle triangle. You can also have a scalene triangle as a right angle triangle. So what actually gives them the name right angle is that 90 degrees, because one of each angle is 90 degrees, just like distance. For instance, this is 90, this is also 90, but they are of different triangles. So what actually makes a right angle triangle? A right angle triangle is that it has one of its angle equal to 90 degrees. So when you look at the right angle triangle, there's one other features it has. This is that the longest side is called the hypotenuse. Yes, this longest side now, this is what we call the hypotenuse. Hypotenuse. Yes, it's called the hypotenuse. The longest side of any right angle triangle is called the hypotenuse. Why do we call this side the hypotenuse? Because it's the side that is facing the 90 degrees. So any side of the right angle triangle that is facing the 90 degrees is hypotenuse, meaning the longest side of the triangle. So this is hypotenuse. So we call here the hypotenuse. So these are the things you need to know about the triangles. So when you look at the right angle triangle, this is the base. Like I've earlier told you, we said something about the past. This is the base. This place is the right angle. You can call it the right angle. And this is the height. Like I've earlier told you, the vertical height. This is the height. Sorry. Height. That's the vertical height. So this is a right angle triangle. So this is also a right angle triangle. This is the hypotenuse. This is the base. This is the height. At this point is called the right angle because that's where the 90 degrees is. So they are all right angle triangle. Now we'll have the last and not the least, which is the fifth part of the triangle. We'll have what's called the obtuse triangle. Obtuse angle triangle. Obtuse angle triangle. Yes, when you talk about the obtuse angle triangle, it's a triangle that has one of its angle more than 90 degrees. Any triangle that has one of its angle more than 90 degrees can be called what? Obtuse angle triangle. You can have a triangle that have this shape. Let's say, for instance, we'll have a triangle of this shape. Let's say you have something of this nature. Let's take a shape of this nature. Maybe this is joint. You join this point with this other point. So you have here, let's say here is A, B, and this is C. So if you look at the angle here, suppose this is a straight line. If you have to project this line now, this is the angle on a straight line. This is the highest angle of these two angles. Now this angle here is more than 90 degrees because if you have to go vertically up, this is 90. So it is more than 90. So this angle is called obtuse angle because the angle right here is more than 90 degrees. It's greater than 90 degrees. So that's exactly what we call the obtuse angle triangle. When the angle here is more than 90 degrees, it can be called an obtuse angle triangle. So let's go back to the types of triangle again. I told you earlier that the equilateral triangle is a triangle that has all the sizes equal. Since all the sizes are equal, all the angles are also equal. And one of each angle there is what? 60 degrees. Remember that the sum of angle in a triangle is 180 degrees. We also have what we call the isosceles triangle. The isosceles triangle is a triangle that has two of its sizes equal. If the two sides are equal, it means the base angles are also equal. We also have the scalene. The scalene triangle is a triangle that has three unequal sizes and angles. So if all the three sizes are not equal, the angles are not also what? Equal. Like example, you have 90 degrees here, you have 60 degrees here, you have 30. They are not the same just because of the different sizes they have. That's why we call it scalene triangle. We also have the right angle triangle. What actually makes a right angle triangle is a triangle that has one of its angle as 90 degrees. Like for instance, this is a right angle triangle. The isosceles triangle we drew here is a right angle triangle. The scalene triangle is also a right angle triangle. We also have the obtuse. Now the obtuse angle is a triangle that has one of its angle more than 90. As you can see, this is an obtuse. The angle here is more than 90 degrees. So that's exactly what an obtuse is. So it means that the theta here, supposing we use theta to represent the angle, it means the theta here is greater than what? 90 degrees. That's what an obtuse is. So that's exactly what obtuse angle is all about. So that's exactly. So while in this case, the theta here, if you have to call here theta, the theta here is equals to 90 degrees. So that's exactly what right angle triangle. So a right angle triangle is a triangle that has one of its angle as 90 degrees, and the obtuse angle is an angle that a triangle that has one of its angle greater than what? 90 degrees. So that's exactly what the types of triangle is all about. So that's it for that types of triangle. Now we want to look at the third subtopic. Remember when we started, we said about the definition of triangle. We started with the definition of triangle. That's number 1. We said something about the definition of triangle. And I told you a triangle, as earlier said, a triangle is a plane figure bounded by 3 sizes. A plane figure bounded by 3 straight lines. So that's what I told you what a triangle is. So a triangle is a plane figure bounded by 3 straight lines. These are the 3 straight lines. So all these things are the 3 straight lines. So any plane figure bounded by 3 straight lines is what a triangle is. After that, we were able to look at the types of triangles. I told you that in types of triangle, we have a good example like the equilateral triangle, and the isosceles triangle, scalene triangle, right angle triangle, and obtuse triangle. Now we want to look at the third one, which is construction. That's what the topic is, construction of triangles. We want to see how to construct triangle. Now to construct triangle, there are 2 things that are involved. 3 things must be given to you. It's either 2 angles are given to you, either you're given to draw triangle with 3 sizes, or the 3 sizes are given to you, or maybe 2 sizes and angle is given to you. This is what is involved. So these are the major things that normally comes when it comes to construction. Now supposing you are asked to construct a triangle. Example, we are asked to construct a triangle. Let us start with to construct triangle 1. To construct triangle. To construct any triangle. Triangle given the length of the 3 sides. Now let's see, to construct a triangle or any given triangle given the length of the 3 sizes. To construct any triangle given the length of the 3 sizes. Now let's look at this example. We ask example. Construct a triangle with sizes 3 centimeter, 6 centimeter, and 7 centimeter. Now let's look at this example. You're asked to construct a triangle. Remember, this is objective. We started by telling you the types of the definition of the triangles, types of triangles. That's number 2, types of triangle. And this time around, we want to look at construction of triangles. That's number 3. To construct any triangle given the length of the 3 sizes. Now, we want to construct a triangle with given the 3 sizes. Now, to construct any triangle given the length of the 3 sizes, we have example here where you are asked to construct a triangle with sizes 3 cm, 6 cm, and 7 cm. So how do you go about this? First of all, you have to draw a horizontal line. Now to answer this, draw a horizontal line Right, let's write solution. Let's draw a horizontal line. A horizontal line AB. Let's start from here. 7 cm. Let's start with the longest. You have to use. Let's use the 7 cm as our longest line here. 7 cm AB. Let's assume that AB is 7 cm. You can see from here to here is 7 cm. Okay, let's indicate here as A and what? B. Now, you have indicated here as 7 cm. This is your 7 cm. Let's say we are our AB, size AB is what? 7 cm. Best side AB is 7 cm. Now, having done this, we have drawn the line AB 7 centimeter. Now, the next thing we're going to do now is to look at the other size, the longest size. Now, you have to, that's where your compass has to come to play. Now, using your compass, you have to center A, and the radius of this size. Remember, let's assume we want to take a side AC. Let's say we are AC. Let's call it AC. AC is 6, this 6 cm. Let's assume this 6 cm is AC. Then let's continue now. And let's assume, okay, BC should be the remaining 3 cm. Now, let's take this. Now, I've drawn the AB, which is this. Now, the next thing you have to do is to center your compass as point A. That's the end of the line A. Then, before you center it, take a measurement of 6 cm because we want to get C. C should be lying around this way. Remember, if we have AB, C should be lying. We don't know where C is until the point of intersection of the arcs. So, since AB is 6, so to get our AC 6, you just measure 6 centimeters. 6 centimeters can be measured from this point. 6 cm, expand it. Keep expanding the radius until you get to this point. Yeah, that's exactly what 6 cm is. You can see now from here to here is 6 cm. So center at point A, that's the end of the line AB. Draw an arc. This arc is passing through the point where the C will lie. We don't know actually until when there is intersection of other curves. So this is 6 cm arc from the radius point A. So this is 6 centimeters. The distance from A to where the C should lie is 6 cm. Any point where we draw this arc is just 6 cm away from A. That's what it means. Now we'll now draw the next one, BC. So BC should be around this area. So our BC, where our BC here is 3 cm. So you measure 3 cm. 3 cm. This is 3. I hope you're seeing it now. This is 3 cm. Measuring from 3 cm. You center at point B. This is point B. Center at point B. Then bisect the previous arc. Although it couldn't touch it, but we'll still go back to right. So around this area now is where 3 cm you have. So the point of intersection of the two arcs will be the point C. So you go back to this, since the A could not meet, go back to AC, which is 6 cm again. Take that 6 cm to make sure this arc completes or bisects or meets the other arc. So by doing this is 6 cm. So go back to that point at the center. You can see exactly it's passing through this point of the arc. So intersect the previous arc. So there's a point of intersection between the previous arcs. So at this point where they meet now is your point C. So this is point of intersection where these two arcs meet. Is point what? C is your C. So how do you draw the triangle? So join this point of intersection with from A, from the end of the line where A is. Join it this point. Make sure it's passing from the center. Draw, join this point, then come to this point, join this other point, and this point to this other point. So that's exactly the required triangle. This is the triangle. This is the required triangle. The required triangle. So this is the required triangle. So how do you know that it's the required triangle? Now let's look at it. Remember we said our AB is 7 cm. We have already measured 7 cm. Yes, you can see exactly from A to B here is 7 centimeter. Then measure the AC. Let's see whether it's going to give us 6 cm. Let's see whether AC will give us 6 cm. And from that point A to C, point of intersection, you can see it's exactly 6 cm. Are you seeing that, student? Can you see that? So it's exactly 6 cm. You can see it's just exactly. So now you measure this. So you write in the record that this is 6 cm. 6 cm. Then measure this other side and check it. So you can see this is exactly from the point of intersection to where the B is 3 cm. I hope you're seeing it, students. So that's it. So you record here 3 cm. So this is the required triangle. So you have AB, which is 7 cm, and AC, which is 6 cm, and BC, which is what? 3 cm. So this is the required triangle. So whenever you're drawing this, can reduce the arc, use a thin line for construction. So this is the required triangle. So if you're asked to construct triangle given the three lengths, this is the procedure you have to take. So remember a recap. Let me make a summary of what we did. If you're given to construct a triangle with three sizes, 3 cm, 6 cm, 7 cm, the longest side you can indicate it as your AB. Although you can start with any, you still get the same shape of the triangle. But start with this. AB should be 7 cm, which we have done. You measure your rule. We measured a straight line AB. Then that's 6 cm. Then to get the other length, what you have to do is to use your compass. Like to get for AC, line AC, you measure 6 centimeter. Center it at point 8, draw an arc. Then to get BC, you measure 3 centimeter. BC is 3 centimeter. Measure this 3 cm. Center it at point B, draw an arc, which bisects the previous arc. So point of intersection of this arc gives you the point C. So use the straight line, join AC and the PC. That gives you the required triangle. So that's exactly how to construct any given triangle with 3 sizes, or to construct any triangle given the length of the 3 sizes. So whenever the length of 3 sizes, this is size 1, size 2, size 3 of the triangle. Remember we told you that triangle is a plane figure bounded